Stole our thunder. All right, go ahead.
Thanks, everyone. So actually, we did change our name. We changed it to experience-based. That's because we realized, after talking a little bit, it really wasn't all about projects, that we were bringing in lab projects, but also simulations and online collaborations and games and many other aspects. And Steve mentioned this sounded like The Matrix. So we went with that. And then we all realized we know Kung Fu, so that cemented it. But what is project-based, experience-based learning? So again, when discussing this, we found it was hard to come up with a definition that encompassed everything that we wanted, but it was easy to come up with lots of examples. And so within our own group, we have, for instance, Katie's work with her projects that she incorporates into her wind energy graduate course, or Conrad has a engineering design course that they incorporate a Kinect camera with a virtual reality environment and interface these two devices. But again, it incorporates many, many other things. So this includes games, field trips, international collaborations. Perhaps the most extreme example of experience-based learning would be the PhD dissertation. Many of you have discussed some of these aspects in experience-based learning, and some of you have explicitly incorporated experience-based components into your presentations today. It's a little bit easier to discuss why we want to do this. I think we've all seen that if you go really deep, really quick into theory, the students can become frustrated or bored. We also see a need to connect abstract ideas to concrete concepts. So they learn theory, but they need to know what constraints they're going to see in the real world when they try to apply these things. Also, to fail, because they're going to have modeling errors. They're going to have noise that they don't see in the theoretical aspects that they're going to encounter in real life. Then also, this is a way to address alienation of certain subgroups, that by incorporating multiple learning styles, teaching styles into your class, by explicitly showing the end effects that these classes are going to have, so they see the impacts they can have on people's lives, on society, on the environment, etc. And also to reinforce human interactions in the classroom so that people are drawn together, that it can improve some of these problems we've had with underrepresented groups. So our experiences, we see a lot of pluses, minuses, opportunities, and challenges. There's definitely a lot of student excitement and pride. Conrad talked about his students showing their friends what they had built in the class. There's discipline interaction, both amongst multiple classes they may be taking at the same time and classes they've taken previously. Real-world workforce preparation, and there's been a lot of reports back that employers have been very happy with project experience-based learning. Also, there's a good opportunity to leverage your research into the classroom, and also to use students as resources that people, several of us reported, that we can have independent study students develop aspects of these experience-based learning modules. And in fact, part of the experience-based learning can be refining and improving the experience for the next iteration through. There were, of course, challenges too. A big one is cost effectiveness, that we have limited resources, not only just in money, but in time, in space, et cetera. And how do we properly have something that's robust enough, but also affordable? There's accessibility issues. You may feel pushback from students and from colleagues who are invested in more traditional ways to do things. But really what we spent a lot of time discussing challenges was assessment, and proper scale-up. What is the end? And by answering these two questions, we think we can take what has been our experience and make it into something that's more fundamental and established.
All right, so I'm going to talk the last little bit about the assessment and the scale-up pieces. And you'll see here a few of the notes that we put up related to scale-up. But we were talking about adoption from peers and other institutions and partnering, and especially actually partnering outside of the engineering educators realm with the engineering education researchers, which many of us have already partnered with, but we really think that this is an important factor for large-scale scale-up if we want to do it right. Things like accessible online resources, we've heard some examples of that, would also help with scale-up. broadening impact to non-STEM students. One of the earlier presentations did a great job discussing that, overcoming language and cultural barriers for international research. These are all really important factors for scale up. But we really kind of felt like it didn't go far enough, and we really wanted a broader vision. So we started thinking, okay, what do we want to see at the end, and how do we work backwards from that? And we ended up sorry, I motivated too fast. I forgot there was an animation. This is our comic. If you can't read that, it says, got a few problems going from lab scale up to full scale commercial. So, can see a little bit of issues here. But anyway, stepping back and thinking about, and this is why we wanted to go last in the end, we started to think about an engineering education grand challenge, and we actually think that 1 year, 3 year, 5 year, none of these are big enough. If we really want to make an impact on society, a positive impact, we need to be talking decades. There are studies out there that go decades, 50 years, 70 years. Obviously, they change PIs along the way. But we really would like to challenge people and ourselves to start thinking about what would a 50-year study to help us innovate, put things into practice, measure success, what would that actually look like? And we don't really know the answer, but we'd like everyone to start thinking about that. And that's all we have. So we're happy to take questions.
Yes. Can you speak louder?
Yeah. The last point about 50 years is quite intriguing, but my question is, given the amount of changes, the pace of change is so rapid, the amount of changes that have happened over 50 years, both in terms of tools and society and style and culture, what relevance is there for this 50 years study? Because a lot of factors have changed, and you need to keep a lot of factors fixed and maybe change a couple of variables to get some meaningful result out of it. So what is that?
So this is an ongoing question that we have to think about. I think a different domain that may motivate us is the healthcare domain. So typically there are longitudinal studies to quantify the medication effects 10 years or 20 years in advance. And so if you think of the human body as a dynamic system that evolves over time also, there are a lot of complexities in those types of studies, and perhaps that may help inspire us in the engineering domain to address these types of studies.
And if I can add to that answer, is that this is not one study that starts at a certain time and ends in 50 years from now. This is an ongoing database that you continue, you refresh, right? But you have that data, so it's Eulerian and Lagrangian, right? So it has to have those two components in it.
And many of the things we're trying to do, like reduce the alienation among subgroups, that's going to be a change that takes a lot longer than 5 years.
And just as a comparison, if you look at the language acquisition, developmental psychology, they usually take 10, 15, even longer number of years to finish a study. So we believe this is not too much to ask.
Other questions?
So I just want to say something. So, I think this is a very important point. And as a dean of engineering, we track retention and graduation rates, but if we look at the time constants, you're absolutely correct. They don't change over a couple of years, not even 5 years. They change over 10, 15, 20 years. And the hard part is keeping people on task, right? Stay focused with the original innovation. Refine it a little bit, but keep looking at the cohorts as they move through the curriculum. Most provosts and most presidents don't have patience. Even faculty don't have patience. So I agree with you. These longer studies are needed over 15 to 20 years, and I really commend you for
involving K-12, you know, I mean, I'm really interested to see where those kids go. And, you know, NSF will fund our project for 5 years, and then the expectation is that then it just ends. So we have to find someone to hand it off to. That process is really fraught, right, to sustain something like that. We're hoping to do it, but.
Yeah, we were hoping that a certain academy would do it.
Thank you.
Thank you.